Let's review the mesh. I will exit Design Modeler, go back to the project and double click on Mesh to start the mesher. And you can say View, Front View to get this view. Highlight Mesh to look at the mesh. And you see, you have coarser elements or cells away from the airfoil, and here there is a circular area where I have finer elements. So let's zoom into that using the right mouse button, and you can see that that has much smaller divisions than that, and that's controlled through this body sizing. And you put in a sphere of influence. So if you do mesh control sizing, and then you can say type sphere of influence, and in this particular mesh the sphere radius is set to 3 times the chord length, and it's centered around the leading edge. With 2020 hindsight, it's probably better to be centered around the trailing edge, because you can you'd cover a greater distance behind the airfoil, and capturing the wake accurately is important. And the element size is 5% of the chord. So that, each element length, if I zoom in further, each of those lengths is approximately 5% of the chord. And going down, there's an edge sizing on both the upper surface and the lower surface of the airfoil. And there's a biasing, so you have, and it's bidirectional, so you get smaller divisions towards the ends and larger divisions at the center. And to see that, go highlight the mesh. And if you zoom into the leading edge, you see that these are smaller divisions and these are larger divisions. So that's the effect of the biasing. And you will see a similar effect at the trailing edge, because it's a bidirectional bias. And this bias factor is the ratio of the largest division to the smallest division. So the larger the bias factor is, the more biasing you're going to get. And then there is this inflation that is used to resolve the area right next to the surface. It's usually called a boundary layer mesh. The ANSYS mesher calls it inflation, so you can see the effect of that inflation mesh. Here there is 1, 2, 3, 4, 5, 6, 9, 10. There are 10 layers, and each layer is growing at a rate of 1.2. So each successive layer is 1.2 times the layer before it. And let's take a look at the inflation settings. Okay, so number of layers is 10 that we saw. The growth rate is 1.2. I alluded to that. And then the maximum thickness is it's 0.6% of the chord, and that controls basically that height over there. And the idea of inflation is, you take the surface and you inflate it, and then you fill that region between the surface and the inflated surface with the number of layers you specify. And at the trailing edge, you can have issues with inflation, we have found. And their biasing towards the trailing edge really helps. And you can see it's not bad, but it's a little bit coarse right at the trailing edge, and that's something one would have to go and fix in the verification step.